Okay, so this lesson I'm going to teach you three other shapes. Teach you how to do it in the calculator. It's all the same. The three shapes we're going to talk about are square roots and cube roots. So the first thing is we're going to talk about square roots. I forgot to change the title though. So square roots. Square root, the square root symbol is called the radical. And anytime you see a radical, it's going to have this basic shape that looks like this. Has a starting point and then it goes up and to the right. So that's another shape that you need to memorize. So far we have the parabola, which is an x squared problem. You have the absolute value problem, that looks like a V. And now your square root has the dot and goes to the right. Now this is the formula for the general square root. If you guys take a look, you may notice it's got the A in the front, the H in the inside with the K, with the X. So in all of the other ones, they have lines around it, but this time it's got the square root around it. So then the last one is the K. Now every single one does the same exact thing from before. The reflection is when A is negative. The vertical stretch is when A is bigger than 0. So taller is A bigger than 0. Shorter is when A is a fraction. The horizontal shift is still opposite, and it's always on the inside. And then your vertical shift is your up and down. That's the one that's on the outside of the far right. So nothing changes, okay? Also, I forgot to mention, the starting point for this is just HK. And you'll notice that's going to be the starting point for every single shape. Keep in mind the H is always the opposite sign. So calculator work now. So if we're going to do this in the calculator, we have to know where the square root button is. To access the square root button, we would hit Shift, which is the yellow button, and then the x squared button. So that gives us the regular square root. Then we put the x inside, and there's our graph. So we can hit trace. So our first dot is at 0, 0. And remember that a lot of our parent functions pass through 0, 0. So then we go into 1. So it crosses at 1. So we can go into 2. Now this is how I differ from some of the other teachers. Some teachers may have you estimate the 1.4 that you see right here on the bottom right of the calculator screen. I don't really care about decimals. I usually just go to the whole numbers. So I'll just keep typing it in. That's 1.7. There it is. At 4, it becomes 2. So 1, 2, 3, 4, 1, 2. So I just use whole numbers because when you estimate, it throws things off. And when you throw things off, then your line doesn't come out very smooth. Let's see what we got here. So I'm going to keep typing in stuff all the way till I get to 10. So 5 doesn't work, 6 doesn't work, 7 doesn't work, 8 doesn't work, 9 finally works. So at 9, we're finally up to 3. So you can see this graph goes pretty slow as it goes across the graph paper. So this one had a vertex at 0, 0 because it didn't have any numbers anywhere around it. Okay, the next one. So again, we can find the starting point just by looking at the opposite of the number that's inside, and then the number that's at the end, and there's nothing here, so that's a 0. So that means this graph is going to start here. So if I was to go into the graphing calculator, I'd hit exit to go back, delete this, shift, the x squared button, and now we just have x plus 1. So if I draw that, same exact graph, it's just one spot to the left. So if I hit trace, it's got a spot at 0, 1. And then I can keep typing in the numbers like I did before. So at 1, it's a decimal. At 2, it's a decimal. At 3, it's finally at 2. So 1, 2, 3, and then 1, 2. Oh, let's move this out of the way. Okay, and then we go back. I type in the 4, decimal, 5, decimal, 6, decimal, 7, decimal, 8. There it is. At 8, it becomes 3. So 8, 1, 2, 3. So this graph, it just shifted left 1. And we knew that was going to happen because that's what this does. Okay, next. Again, starting point. If you look inside with the x, there's not a number, so it's 0. And then this is going to be the y-intercept. So we would go down to -3. Go into the calculator real quick. Exit to go back. Clear this out. So we'd have 2 square root x. Make sure you get out of the square root by hitting the arrow to the right. You can see the cursor gets a little bigger. And then it would be, I believe it was -2. I'm going to take a shot, just kind of guess it was -2. -2. Move this over. Oh, that was -3, my bad. So I can go over to the side. I don't have to clear out the whole thing, I just go to the side and delete the -2 and change it to a 3. So as expected, if I hit trace, it's at 0, -3. Now I hit 1, and it goes to -1. Oh, I missed it right here. Now if you notice, take a look at these first 2 points. This goes up 1 and over 1. This one goes up 1 and over 2. So it's almost like this is the slope. The thing is that it's not a line, so it's not always going to do that. But it is going to cause the graph to be taller because that's A. A is higher than 1, so it's going to make it taller. It's a stretch. So we can go back in and start typing in our stuff and see if we can find more whole numbers. So 3, 4. 4 is at 1. 1, 2, 3, 4. So it goes here. And I'm just going to keep doing it until it runs out. It goes to the end. So 5, 6, 7, 8, 9. There it is. At 9, it finally reaches 3. So if I was to actually take that shape and put it on top of this one exactly, you can see it's taller. That's because of the 2 in the front. It makes it a stretch. So we've already gone through all the different changes, so we're going to sail through this stuff. The impacts, A could flip it, that's a reflection. A could make it taller, that's a stretch. A could make it shorter, that's compression. H moves it left and right, and then K moves it up and down. So we could actually write these problems given these transformations. So so I wanted to show you that now that this has a 3, we call it a cube root. Now, it's a new shape. If you remember a square root looks like this. A cube root just gets the other half. That's what a cube root looks like. So all the rules stay exactly the same. If I need this graph to go up 1, so if I have so they want me to write cube root, so 3 goes here, x goes on the inside. They want this to go up 1 would be out here, left 5 would go on the inside, but it would also have to be the opposite, so it's +5. That would be the equation for this. So write a cube root, so y equals cube root x, so we want right 8, so that's actually -8, and then up 5 is +5. Okay, next one, y equals cube root. We want down 2, so down 2 would be out here. Left 16 would actually be +16, and then they want it to reflect vertically, so we put a negative in front. So you can see none of the rules change. The only thing is like if we were going to have to graph with the calculator, which I didn't put on here, if we had to graph a cube root in the calculator, to access that button, let me clear this out. It's almost like putting in a square root. Say delete. It's almost like putting in a square root, but we just go next door. So I go to that's called the caret key. It looks like this. It's right next door to the x squared button. So what it does is it gives you the option to put whatever number you want on the little step. So we're putting a cube root, and then we put the x on the inside. And as promised, it's like the square root shape, just both ends down. Now these shapes, they're pretty awesome because like domain and ranges for them are always negative infinity to infinity for both of them. That doesn't happen on the x squared, or the what do we call it, square root, because it doesn't go to the left, it only goes to the right. So the only difference here, you got to read the directions. Square root equation, y equals, so I want a square root. Square root is just blank right here on this step. So I don't have to put a number here because it's already understood to be a 2. Left 5 would be +5, and then up 1 would be on the outside. Next one, square root. Right 6 would be left -6, down 14, and then the reflected, I don't know why they even say vertical. A reflection is the negative in front. Okay, final one, y equals square root. So again, reflection. We've got the, so we only have 2 things, a reflection and up 6. So this doesn't have to be that long because up 6 is on the outside. So you can see, like, hopefully you can see, the AH and K stuff doesn't change. The only thing that changes is the symbols, like the squared, the square root, the absolute value, the cube root, and as a result, that's what causes the shape to change. So we're going to talk about, let's see, we got the graphs here. I think I'll skip the graphs so I can make this lesson a little shorter and we can have more time to practice. But I want to talk about this again right here. We talked about this once already. They want you to compare the old one to the new one and talk about how it moves. So I'm going to show you one of these examples right here. So I'll do the second one. So the original is this one right here. So it has a starting point at -1, 0. Why is it 0? Because over here at the end, there's no number. So that's a 0. So what we need to do is we need to take a look at the new starting point for this graph so that we can decide how it's moving. So if I put a -1 on the inside, that takes it to +1. If I put a -5 on the outside, now it's at -5. So when I talk about how it's moving, I compare the x's first. So just looking at these, and you can even think of it as being on the x-axis. If I start at -1 and I want to go over to 1, that's 1, 2 spaces. So I went to the right 2 spaces. Oh, I almost combined everything. Let me write that again. Right 2. I can do the same thing for the y's. The y's are right here. I'm starting at 0 and I'm going to -5. Now the y-axis goes this way, so if I'm at 0 and I go 1, 2, 3, 4, 5, there's -5. So if I start here, it's 1, 2, 3, 4, 5. So this means that it's down 5. Now the other thing you got to watch for is they put a negative in the front. They try to be sneaky, those little rats. So what we do here is just remember that anytime you see a negative in the front, that's a reflection. So don't forget about your reflection. Okay, cube root graphs. We can do that stuff in the calculator. Same thing as before. Just use the trace button and manually type stuff in. Because there's one more thing I want to talk about. I didn't throw it in the notes, but I'm going to talk about it anyways. We're going to talk about regular cube. Not cube root, just regular cube. So regular cube looks like this. It's got a 3 on it. And that shape almost looks like a parabola, except the other half faces down. And the left side is always down, the right side is always up. Now these ones, they have a nice domain and range also. Basically anything with an odd exponent or an odd root, they'll have a domain of -infinity to infinity and a range of -infinity to infinity also. Same rules, guys, like I told you. I've been trying to stress this A, H, and K stuff. So what makes it a cube? It's got a 3 out here. So we've got those same 3 letters as before. A is in the front, H is on the inside, K is at the back end. So we have minus and then plus right here. They do the same exact thing. This guy flips it if it's negative. It also makes it taller if it's higher than 1. And it also shrinks it down and makes it wider if it's a fraction. So that does 3 things. This one causes it to move side to side, and this one causes it to move up and down. And don't forget the one special thing about H, it's always opposite. So how do you type that in the calculator? If we were going to type that in the calculator, go up and clear this out. If I was going to type that in the calculator, I type x, and to change the exponent to something other than 2, I go right next door to the x squared button to the caret key. Caret key looks like this. What that does is it gives you a little box that allows you to put whatever exponent you need it to be. So if I put x to the 3rd, there's that picture I showed you. I'm almost perfect. Look at that right there. Looks just like the calculator. So that's it, guys. That's all the shapes for the entire chapter. We learned 5 different shapes. Quick summary of all of them. So we learned about absolute value. That shape looks like this. We learned about quadratics. That shape looks like this. We learned about square root. That shape looks like this. We learned about cube root. That shape looks like this, except the other half. And then we learned about cubics. That shape looks like a parabola, but the other side just goes down. So all of these shapes, this one, this one, this one, and this one, they have domain and ranges from -infinity to infinity. The only one that doesn't is this guy right here. So again, if you memorize these shapes, you memorize what they're called, you memorize the characteristics of the equation that makes it be that. So this is what makes it absolute value, that's what makes it squared, that's what makes it square root, that's what makes it cube root, that's what makes it cube. Once you have that memorized, we use these things in college algebra all the time, so that'll make the next math class easier if you take college algebra. So, basic summary, those are your shapes. Where do you find A? A is in the front. Where do you find H? H is in here with X somehow. And depending on which shape you're looking at, it could be these, it could be the square root, it could be the cube root, it could be cubed. So it just depends on the shape, but bottom line is the H is always, always, always with the X somehow. And then your K is always at the end. They have the same effect on every single picture we know. And that's pretty much it for the chapter.